first. Okay, we are still in chapter 19, patching faster translation, and currently on homework measurement here. Let me open that. Okay, we are in this homework measurement, basically trying to measure how long we can access the page, I guess, something like that. Okay, let me open that terminal emulator here. First thing first, I feel like I'm gonna using this one as the measurement mechanism, maybe something like that. Okay, measurement. Alright. Okay, let me put that in the library. But wait, can we use this in the library name? I am not sure, so let's try that out. Check. Lips. Yeah, I don't think we can do that, but let's find out. I don't think we can use this. Okay, let me change that to underscore. Oh, wait a minute. Chapter 19. Okay, interesting. Oh, wait. Yeah, I need. Okay. Let's do that. I need to put this. Okay. Are we? Okay, can we like using this? as the library directory. Interesting. Wait a minute. I kind of forgot what this do. Oh, okay. Yeah, we read it from the standard input. Something like that. I'm not sure if I want to name the directory like this. See, programming. Include an external library. Okay. Okay. Yeah, for now let's call it this one, I guess. That's one thing. This is another thing. Yeah, as an example that we can use this as the, what is it called, directory for the include here, maybe something like that. I mean, yeah, we added this in here, right? I didn't realize that. Okay, let me try this. Context switch. Alright. And then, no, not this one, but this one. I think okay, let me commit that. Okay, check the okay. Refactor move measurement into planning to use this this measurement skip another measurement as a dedicated library, maybe something like that. And take the measurements give us or maybe stand alone. At this. All right. Okay, with that in mind, I need to change this to next local. Something like this, and then, well, yeah, let's do this first. I mean, because we have multiple clock get time, right? The first one is when we start the timer, and the second one is when we get the end time. So it's kind of confusing if we didn't put the line number, I guess. Let me check. I feel like I've done this previously. Oh, okay. Looks like we can use the str error. Okay. pointer to char. Alright. I'm kind of curious. Is NPTR here need to be pointer to char, or can be pointer to constant char? Okay. I don't know. Okay, we already have Erno. Something like this. And then the printf. Returns pointer to a string that describes the error code passed in the argument error. Okay. Okay, something like this. Okay, and then I'm trying out what is it called? The Linux kernel style, I guess. It's putting the conditional right after the thing that we check. Something like that. Extra, I can forget. What is it? Run, I guess. Yeah, I want to check the flag that I use on my previous project. Situ red string. Wait. Chapter 19. Let me check. Okay, right. Delete string and then from in. Okay, right. We need to provide this one too. So we haven't used total page and trial yet. Okay. TLP. Total page number trial. Okay. Total page. Try 5 and then the trial. Okay. Want to put something like this. First invalid character. Okay. Yeah, that make me curious. I think doing something like this is fine. Oh no, okay. Incompatible pointer type. Okay, interesting. Okay. Pointer of pointer. Okay. Yeah, we can check from the return, I guess. Well, maybe putting the line number here is also beneficial. Maybe total fail. The line number is here. Invalid character for number. Yeah, let's use printf. I mean, I can put this in one line. So that the line number is represent the correct line number. Okay, something like that. But I prefer this format. I feel like this is easier to read. Again, this is just personal preference. Something to keep in mind. Oh, okay. Yeah, I forgot to change this. And also this one. You know what? Why don't I create a variable for that? The page is curious. If I remember correctly, long type is sign type, I guess. So it can be negative, maybe something like that. Trials. Okay. Chapter 19. Okay, right. See. So if it is less than 0, right? We throw an error. Should not be negative. Oh no, not that one. Line, okay. Alright. Wait a minute. Oh, okay. My bad. Right. This is the correct one. Okay. And then we need to add this for the previous one. Not trial, but total bits. Okay. Oh, right. I haven't compiled that. Okay. Where is it? This one. Listen to access the array. And to iterate operation to access the array. It may be something like this. Okay. Equal 0 I less than trials. Okay. And then inside this one we have another. I'm kind of curious. Oh, wait a minute. Okay, maybe something like this. Total bits. But here we have two scenario. We're not in it array element. And when initialize array element. Okay. I think from the question here, it looks like this is an integer array. Okay, integer array. Do we need to use variable length array? I don't think so. Okay, maybe right, that is the value of the array, right? Plus 1. If I use long, something like this. if I use something like this, then it become a variable length array. Set but not use. Okay. Is this correct? I'm not sure. Yeah, I'm still not sure about the input to the program, like the number of bits to touch and the number of trials. How are we gonna use this input? The number of trials, I assume. How many we do the scenario, I guess. But this one, the number of bits to touch. What do the program should be? Okay. Total bits. You know what? Maybe only input the trials. Maybe. And then the total bits is something like this. Wait. Yeah, maybe for the total bits, use the macro, I guess. Total bits. Maybe yeah, like how are we gonna use this number of bits to touch? Okay, the bits. Hello, ping pong point. Welcome, welcome. Yeah, well, isn't it too early? You usually stream at 6 a.m. Well, I just want to stream early, I guess. It is peaceful, you know. So there is that. Yeah, there is no specific time. Okay. Now I'm kind of confused. Do we need to use this algorithm? Okay. Numbits multiply by jump, then page size. Numbits multiply by jump. Okay. In this loop, one integer per bits of the array A is updated up to the number of bits specified by numbits. By timing, such a loop repeatedly, say a few hundred million times in another loop around this one, or however many loops are needed to run for a few seconds. Okay, by timing such a loop repeatedly, say a few 100 million times in another loop around this one. Oh, in another loop around this one, or however many loops are needed to run for a few seconds, you can time how long its access takes on average. Okay. Okay, I finally finished my final exam So maybe I'll watch your stream a bit more often. Oh, okay. We just finished of your exam. Well, let's take a break, I guess. Okay. I hope you pass all your exam. Ping pong point. Okay. Happy 500 subs, by the way. Yeah, thank you. I mean, I didn't realize that I already have 500 subs. So thank you for the reminder, I guess. Okay. Yeah. I mean, we are still learning about this book, the operating system 3 Easy Peace, right? And currently learning about virtual memory with the patching mechanism, and now trying out the homework, which make me kind of confused, like how to measure accessing the page or the virtual memory. In this case, basically the goal is to measure, like, to measure how long we take to access the virtual memory, if I understand correctly. Hey, thank you. You are not sick, right? You sound kind of sleepy. Well, I'm trying to keep my voice low, so not to wake up anyone in the house, Maybe that's why I sound like I'm sleepy. So, yeah, I'm basically trying to be as quiet as possible because it is early in the morning. Right. Currently it is 4:30 a.m. in my time zone. So yeah, I'm trying to be as quiet as possible. Okay, yeah, good luck. Don't push yourself too hard. You already did your best. Don't forget to drink some water and eat breakfast. Alright. Okay. Yeah, maybe I sound sleepy because I'm confused, I guess. Like, what is the goal of this homework? Or how do I approach this homework? Maybe that's the word. And it looks like this is the basic loop for that. And I guess the num page is the total page here. Okay. Yeah, maybe this one. We don't necessarily need that as an input to the script or to the program here. Maybe we need only to input the trial. Maybe. I mean, I'm also have a constant but variable length array, I guess. So maybe we can use the macro here so that the array size can be known during the compile time, something like that. But yeah, let's try something simple like this without considering the trial, something like that. Okay. Well, it's okay to feel confused. Don't rush it. Just take your time. Yeah, that's why I'm kind of slow, I guess. I mean, I've done more than 100 parts for this book and still on chapter 19, you know. So I'm taking things very slowly, especially when we are having a coding session or a programming session here, like homework simulation, like homework measurement here, or the homework code like this one, for example. Or maybe the simulation too. Yeah, sometimes I also analyze the simulation, right? The last one is this one, chapter 18, which have a lot of explanation here. Okay, yeah, I even try out what is it called, the range for the page table. Oh right, by the way, the paging mechanism here, if I understand correctly, is that we, what is it called, we put different segments, something like that. We chop up the virtual memory into different pages, which is a fixed size page, and then to keep track of that we need a page table which basically contain the translation, I guess. So I'm not sure if I can explain this. Basically the page table contains the translation from virtual memory address to the physical memory address, something like this. Understood? And sometimes I feel stuck whenever I study both physics and do the exercise. Glad to know you, by the way. Now I have friends to study with. Right, glad to know you too. Well, let's study together, you know. Okay, something like this. The page table. So wait, where am I again? Alright. Yeah, I'm trying to understand what's the page table do, right? Or what it contains. And I assume it contains a range for the virtual address, something like this. So from 0 until 1023, 1024 until 2047, something like that. So this is the range, and then we can get the physical address by translating from this range, if I understand correctly. Something like that. And then yeah, let's continue, I guess. Okay, so we need to put the timing in the loop too. Okay. Alright. So I assume, wait, does that mean the calculation need to happen inside this loop when we try to access the memory? Maybe. Okay, let me try that. Okay. Maybe something like this. Alright, okay. Okay. Prince of time. Okay. Then also the time here, right? Okay. Right. Yeah. Need to argument. Okay. I haven't changed that. Okay. Interesting. Alright, focus time. I'm going to do something that novel got accompanied by you. Yippee, good luck. Alright, enjoy your drawing process, I guess. Okay. Okay, we got the segmentation fault. Interesting. Where we got that? Oh, maybe this one. It is still okay. Interesting. Let me try debugging that. What? Step but oh, okay. I kind of forgot. working, run. No. Need to recommend again. Can we do something like this? No such file, okay. Let me check. KTP input to program. When running a program on GTP, usually the argument for the programmer given at the run command to run the program using GJPN as well give argument. Okay. Args. Oh. Okay. Xrun. Okay, interesting. Change interpretation of command line so that argument following this option are pass all argument to the inferior. On the other hand, using args.gtp with introductory message and pass the option to the inferior. Oh, I can do this. State it. Okay. Right. Looks like we found the problem here. I think where. Okay. I guess we can. Put something like this. Okay, compile that. Okay, Is it nanosecond? Yeah, maybe this is nanosecond. Okay. Let me check. Wait. try something like this. Okay, and then seven one zero 24. So maybe around 4 nanosecond state it. Four to 5 nanosecond to second. Okay. Alright, yeah, this is the nanosecond. Okay. Okay, right. Wait a minute. Okay. Oh, 7 nanosecond. Interesting. Oh, yeah, I feel like there is some kind of pattern here. Five, 4, 5. Okay. Right. Oh, wait a minute. 5, 8, 6, 7. And then 5. Okay. Oh. Okay. Alright, interesting. I assume this one is the first page that we access. So maybe when we have something like this. Wait. try not printing that, not printing the value in the array, something like that. Okay. Oh, it is quite significant, I guess. Yeah, the difference is quite big. Okay, maybe this is the more appropriate example, because when we also, what is it called? When we print it like this, print the value like this, we also accessing the memory gain, maybe something like that. Maybe yeah, from the first access to the second one is significant. But after that, I think it become consistent. Maybe well, let me check, I guess. Okay. Yeah, I feel like it is around 3 to 4 3 to 4 nanosecond. Oh, okay. Yeah, maybe around 3 to 4 nanosecond. Wait, not that bad. Oh, pause and then going back again. Interesting. Okay. Okay. I think integer is fine in this case. Multiply jump. Bit size. Bit size. How many bit size do we use here? If the bit size is 4 byte, it is the size of integer on my machine. Right? Quite different from long here. Okay. Let's try using 4 as the bit size. Integer jump divide by okay, and then jump. Maybe something like this. Wait a minute. If I remember correctly, right? J is long. Maybe something like that. let's call this usage. Okay. Do you go to work from noon till night? No. I am. Well, most of the time I'm trying out something, I guess. Not necessarily work. I'm learning about the Linux kernel usually. I mean, if you know about the, what is it called? Yeah, for example, I'm learning how to debugging the Linux kernel during noon. Oh, wait a minute. Linux kernel mentorship program wiki. So I found this, right? Mentorship program about the Linux kernel, and then I read some of this. I read some of this blog post. Where is it? I think this one. Yeah, I read this blog post during noon, basically trying out the Cscaler tool to find bug in the Linux kernel. And yeah, I'm trying this out, trying to see how debugging Linux kernel during the noon, I guess, right? So there is that. Not necessarily work, but yeah, another exploration which I didn't do live stream. Okay, but yeah, off stream I usually take a look at the Linux kernel here, trying to understand how to fix bug in the Linux kernel. We can use Scaler, and then there is also Smash. What is it called? Smash static analysis. Okay. Yeah, this one. Another analysis tool for the Linux kernel. Let me copy this in the chat. I took your code to work. Sorry if it's a bit personal, I'm just really curious. And no worries. Yeah, basically that. So yeah, I'm not going to work during afternoon I'm exploring the Linux kernel instead. Maybe after I'm done with this book, I might doing live stream about the Linux kernel, but yeah, for now let's focus on this book first. Okay. Printf. Database. Yeah, maybe something like this. Okay. Invalid character for number. Oh, wait a minute. If I do this, invalid character for number, and why the new line is there? Like that's more like it. Okay. File line. Okay. Alright. Total bits. Wait, right. I need to multiply this. Oh, I already did. Okay. Interesting. The first access is quite fast. Right. Okay. The first access is quite fast, but the second one starting to increase, I guess. So what happened here? Pas jam. Okay. Yeah, I mean the petzas is for byte, so the jam is only one. There is that, I guess. What about 8 byte? Okay. That's amazing. Okay. It's amazing to detect that. Right. I guess because what is it called? We are more than the total bits. total bits. Okay, the basic idea is to access some number of bits within a large data structure, for example an array, and to time this access. For example, let's say that the TLB size of a machine happen to be 4, which would be very small but useful. For the purpose of this discussion, if we write a program that touches 4 or fewer bits, its access would be a TLB hit, and thus relatively fast. However, once you touch 5 bits or more, repeatedly in a loop, 5 bits or more repeatedly in a loop, its access will suddenly jump in cost to that of a TLB miss. The basic code to loop through an array once should look like this. I'm assuming the total of the array is num bits multiplied by jump. Maybe. Okay, if that is the case, num bits okay, maybe num bits, right? Let's say 10. We have 10 bits, and then the total bits here is the num bits multiplied by bit size divided by size of in or maybe we can do something like this. Array type. Yeah, maybe something like this. And then can we do this? Yeah, that. I'm not sure if we can do this. And well, oh. Jump type something like this. And then this one. Jump array. Maybe the array type. Okay, and then let me check. Okay. I cannot do that. Okay. Comparison of integer expression of different size. Okay. Long. Long unsigned in. Wait. Did the J long unsigned in? Oh, because of the size of isom. Maybe if I do something like this, okay, what would happen? Still the same, huh? In and long unsigned in. Which one is in and which one is and which one is long unsigned in? I assume okay. Yeah, I assume it is from the size of, I guess. Maybe Jam page size 6 page. Okay, 6 page multiply by jam. Hello, get inspired and pray. Welcome. Size of is unsigned in. Set the division between an in and an unsigned in. In your define total bits, result in an unsigned in. Yeah, this one because of the size of, right? Okay. That make me wonder. Maybe I should just use size T for that. Something like this, maybe. Ooh. But size T might be longer than long. Well, let's see. Okay, total bits. Okay, maybe we don't need that, and we can just use this. Okay. Alright. Total bits 10. Bit size 8. Okay. About this one. 1K bit size. Okay. It is still the same. The first, what is it called? The first access is fast, but the rest is, well, relatively slow compared to the first one here. Maybe all of this is the TLP miss. Is that it? Maybe. the second level TLP axis. Second level TLP axis. Okay, maybe something like this. The 4 kilobyte. Okay. Number of pages. That kind of made me curious. Let me try to print that. I guess something like this. The size of in. Page size divided by size of page size. And then every by 1 jump. I'm not sure if that is necessary. Something like this. I'm assuming we are hitting the TLP hit. Okay. Yeah, I don't think we need this. The page. Okay. Alright. This is quite interesting though. The first access is relatively fast compared to the rest. But if we try is it? I think something like this. The time is what is it called? The difference is not that big between the first one and the second one. That is quite interesting. I'm kind of curious, can we use unsigned for STL toll? Wait a minute. Something like this. Yeah. It is a bad idea. We got the wrapping there. Okay, yeah. Let's use long so we can validate here. Okay, why I think this make the timing different, something like this. I mean, without this, the difference is quite big. Between the first and second element. Yeah, what happened there? And again, according to the second scenario, when we initialize the array element, let's say initialize to 0 here. It is the same. Interesting. Or maybe something like this. Yeah, I'm still not sure about that. I'm assuming this is the TLP heat, but the rest of this is not. Maybe something like that. Okay, we already done this. The reason for access array element. I mean, I can do this, I guess. No total trial. What about two? We hit TLP miss again. To make things easier, let's put the curly bracket there. Is the calculation correct here? Calculation. In order to time it successfully. Okay. Get a little bit measurement. Okay, well. Okay. I'm not sure if this is correct or not. Hello, swords. These pieces are not easy. Well, easy is relative, right? It's subjective. So for some people might be easy, for other people might not be. Well, for me it's kind of interesting, but yeah, it might not be straightforward or easy to understand, I guess. yeah, that's the part of the learning process, trying to understand what this means. Okay, wait. As you can see in the graph, when a few bits are accessed, 8 or fewer, the average access time is roughly 5 nanoseconds. When 16 or more bits are accessed, there is a sudden jump to about 20 nanoseconds per access. Is this the right question to ask? Maybe. How do we analyze the bits access? Maybe something like that. I mean, is there any difference between only assignment here and also doing the calculation about memory access? I'm assuming we can do this because we already initialized the value from the value for the array here. That's why we can add 1 there. But yeah, the bits access. When TRP hit or miss, let's try exploring this on the next session. So I guess that's it for now. Thank you for watching and see you next time. Bye bye.